Hello and welcome to another video lesson with Mr. Roman. Today our lesson title is Arcs and Central Angles. So first question is, what is an arc? Well, an arc is simply a portion of the circle's circumference. And remember, the circumference is the distance around the circle. And then secondly, how do we name an arc? Well, there are several types of arcs. So we're going to break down some different types here. The first one is called a minor arc, and that's an arc that is less than half the circle. So over here, I've put that here in red. AB here is a minor arc because it's less than half the circle. And the way we would name that is we would use the two endpoints of the arc, so AB, and then put an arc symbol over the top. Next, the second type of arc is called a major arc, and that's where it's more than half the circle. And over here in blue, you see that the major arc goes from A through D through C all the way to B, obviously being more than half the circle. So the way you name that is by using 3 letters instead of 2. And there's a couple different ways you can do it. You use the 2 endpoints of the arc. So here the endpoints being A and B. So you can see here it's A and B, A and B, but then you also use a third point that the arc passes through. So here you could use letter D or letter C, and both of these would be correct for the blue major arc. And the third type of arc is called a semicircle, which is exactly half the circle. And in the same way, you name a semicircle with 3 letters. In this case, you could use BCD or DAB. DAB would be also a semicircle. So here are the examples. It says name 3 minor arcs in the picture. So one of them would be between A and B. That's obviously less than half the circle. Another one would be BC, obviously less than half the circle. And then the last one is CA, obviously less than half the circle. And then here it says name the opposite major arcs for each of the minor arcs. So first of all, we're going to list out those minor arcs again. So let's start with minor arc AB. So the major arc that goes with that is going to go from A, not this direction, but A this direction all the way around back to B. So that would be arc ACB. Then the second minor arc that we looked at was minor arc BC. So again, the major arc that's opposite of that would go from B to A back to C. So you're still using B and C as the endpoints, but then there's going to be the A in between. So BAC is the major arc there. And then the last minor arc was CA. And again, the endpoints of the major arc that's opposite of that would be A, B, C going in that direction. So we would say CBA as the major arc. And then the next question says, how many degrees are in a circle? Well, we know that there are 360 degrees because that forms a full rotation of, or I should say one full rotation. And then we know that the arc measure is how many degrees of the circle that arc represents. So here, if we look at the red and the blue arcs, those represent half the circle in this case. So we would be able to say, well, half of 360 degrees is 180 degrees. So both of those arcs have a measurement of 180 degrees. So we would be able to label that as arc BRD is equal to 180 degrees, and then arc DSB is equal to also 180 degrees. Then let's say we were to cut the circle into 3 equal portions. Okay, so we know that the whole circle has 360 degrees, which means that each of the individual parts, the red, the blue, and the green here, has to be an equal measure of 120 degrees. So that's 360 divided by 3. And so we would say arc AB is equal to 120 degrees, arc BC is equal to 120 degrees, and then arc CD is also equal to 100. I'm sorry, CA, not CD. That should say CA there. So arc CA is 120 degrees. And then in this circle, let's say we cut the circle into 4 equal sections. Well, to find each section's measurement, we would take 360 divided by 4, which would be 90 degrees in each of the quadrants. So we would say arc AB is 90 degrees, BC is 90 degrees, CD is 90 degrees, and AD is also 90 degrees. Now, a central angle has its vertex on the center of the circle and 2 radii as its legs. The central angle has the same measure as the arc that it intercepts. So in this picture, we have arc AB is equal to 90 degrees, which I've shown here in blue. And then if we take and intersect that arc with 2 radii, so a radii being from the center to the edge, so from M to A, and then from M to B, we're going to intersect that arc. So I did that in red here. Well, we would know then that the angle measure AMB is going to be congruent or the same as the arc that it intersects. So if the arc it intersects is 90 degrees, then we would say angle AMB is also equal to 90 degrees. Same thing here. So we're looking at a different arc this time. So here we're looking at arc AB is 120 degrees. And again, if we want to intersect that arc from the center, creating a central angle, we would take a radius from B to M here and from A to M here. So I'll show you that in red. And then we would know then that the angle measure of AMB, that angle is going to be equal to the arc that it intersects. So here it's 120 degrees. That means AMB is going to be equal to 120 degrees. And then lastly, a central angle here we have is 130 degrees. We know that BR is a diameter because it's a chord that goes all the way through the center of the circle. That means it cuts the circle in half, which also means that we know from BAR, that is 180 degrees. So knowing that means that AR has to be 30 degrees. I'm sorry, 50 degrees, not 30. AR has to be 50 because 50 plus 130 has to equal 180 degrees. Okay. So now if we wanted to create a central angle to intersect one of those arcs, then we would draw a radius from M to A. And I did that in red here. So angle AMB is 130 degrees because it's the same as the arc that it intersects. And then angle AMR is going to be equal to 50 degrees because it's equal to the arc that it intersects. So let's go ahead and take a look at that. So 50 degrees. And that concludes our video lesson.